Hello, my name is Andrew Furlotte. I'm from Commerce Township, Michigan. I'll be going to the University of Michigan in the fall, and this is my Altair Global Student Contest submission. Alright, so now that we're actually in the Altair software, you may be wondering, what exactly are we optimizing? Now, this piece is a piece that I designed originally so that it would take a piece of plywood and it would be able to slot in. And then with that, you would be able to hold as sort of like a desk stand this laser sword. And I thought this was a great opportunity to use the Altair Inspire software because it would allow me to 3D print this and save on some 3D printed filament and overall create a less massive object while also being nearly just as rigid. And also I felt like it would create a really, really cool, organic, and futuristic look. All right, so here's the unoptimized design, and you'll see that I actually separated it into two separate pieces, a top half and a bottom half. And I designed it this way, that way when I import it into Altair, I could select this top space as a design space, the actual part I want to be optimized, and then I can leave this bottom part blank, and this can be the critical dimension part that will actually slot into the plywood. Now after I did that, I went down to the material and I selected the closest material to what I have with 3D printing, and that would be ABS plastic. I did that for both the pieces, and then I moved on to creating loads. Now, using the loads tool, I clicked on the support and I made this face as well as this bottom face here supports, just because that's what the weight is sitting on. And then I also went to the top half of the loads and I clicked on forces. And I selected this top cylindrical face here for the faces to be resting on, just because that's what the hilt will be resting on. I set my forces to 20 newtons just because I feel like that'd be around the appropriate amount, just because there'll be two of these holding up the hilt. And then after that, I went over to shape controls and I clicked on symmetric and I clicked on my design space. Now what this does is when the actual design is optimized, it'll make sure that it's all symmetrical, which will look nice. And then one of my favorite tools out there right now, arguably my favorite, is the draw controls. And you can select a single draw, click on a plane, and select a plane. And what this will do is when it actually optimizes the piece, the software will understand what way you're building up or what way you're 3D printing from, to make sure that you don't have to have any really annoying supports or make any impossible geometry. So it's a super handy tool that I find really beneficial as a 3D printer, and it just makes sense to have in a software. So after we've done all of our modifications with our loads and shape controls onto our object, we can go over to our Analyze tool. Okay, so now that the analysis is done, we go ahead, we have the green flag here, we can click on it, we can hit View Now, and what this is going to allow us to do is it'll allow us to kind of visualize in an exaggerated sense what the forces that we're putting on the object will do to it, and this can really help us understand, how this object might behave in real life, and if we want to make any changes before we spend hours 3D printing it. So now that we have that done, we can go over to the optimization tool. We can click on Optimize. Where I like to do maximize stiffness, just because it'll maximize the stiffness and I can give it a target mass that it would like to shoot for. I usually stick around 30%, and then we have our load cases. The load cases we created with load case 1, which is the 20 newtons of force on the top bit, as well as the supports from the bottom. So we can go ahead and click Run on this. All right, so now that the optimization is finished, we can go ahead and click on it, and we can see we have this slider of the topology here, and we can play around with that depending on how much material we actually would like in our design. Usually Altair does a pretty good job of finding something in the middle that works really well. For this case, I like it a little bit thicker than what the optimization recommends. We can go ahead and we can take a look at that, just kind of see how it looks. And you can also run an optimization multiple different times, getting many different results. I quite like this one. Once we find something that we like, we click the fit the polynodes, and what that'll do is that'll help generate a mesh for the actual design that we can then send to Prusa Slicer. Alright, so here we are in Prusa Slicer, and as we can see in the bottom right, a pair of the original design weighs 47.91 grams. And then, if we go over to the optimized pair, we can see that we're now down to 27.17 grams. That's a 40% improvement. Thank you so much for Altair, for their software, and for this challenge. I learned how awesome typology optimization can be and how a 3D computer analysis can help us understand a part and how it would behave in the real world. My name is Andrew Furlotte, and I'll see you for my next submission.